Hi everybody, thank you for attending this Pixie software session. I'm Geoffrey Subileau, I'm the brand development manager at Pyxis.
And my name is Axel Jacquet. I also work at Pixie Software, and I'm a product manager and professional services manager. Thank you for being with us this morning, and the purpose of this session is to present to you Pixie's data preparation solutions. And for that, we'll be using actual industrial use cases, and from an interactive data prep mode to a fully automatic and scalable mode.
Just before getting into it, I would like to ask you who is actually dealing with CAD import into Unity? Oh, that's the majority.
Okay.
And maybe who knows already Pyxis? Okay, thanks. Well. So, what is Pixie software? So we have products that help companies to prepare and optimize 3D data made in engineering and design software for real-time 3D experiences. So those CAD data are usually too complex and too heavy to be compliant with real-time 3D engine and 3D standards in general. So, and I think in fact, we see more and more industrial companies that now want to reuse their CAD data for real-time application built in game engines. And I think this is going mainstream. The core of Pyxis is a library of powerful algorithms that also serve different Pyxis products and solutions that can do simple to complex and scalable CAD data preparation. And Pyxis team, the team is made of automotive industry experts, CAD modeling experts, and VR, AR experts. We recently announced a strategic partnership with Unity, and this is why we are here today, and we'd like to thank Unity for welcoming us. So along with this partnership, Unity announced its commitment to the automotive industry. And so today you can buy a Unity for Industry bundle containing Unity Pro and also Pyxis products. So we'll work closely with Unity to provide you with the smoothest CAD data management experience. So where do we stand? In the 3D experience creation value, we try to fill the gap between CAD modeling tools and staging tools like Unity. So Pyxis is used like a hub for any CAD data input and any kind of use cases. Our solutions can be used by a single person for manual data prep or deployed globally in the company for extensive use. In this case, we work closely with our customers to help them to build large-scale automatic CAD data preparation pipelines. This is our portfolio. We have CAD data prep tools and a CAD viewer called Pyxis Review. But in this talk, we'll focus on CAD data prep tools. Pyxis plugin, which is for direct import in Unity. Studio, which is a prime interactive complete toolbox for CAD data prep. And Connect, which is a solution to deploy automatic data prep globally in the company.
Thank you, Jeff. So before even starting presenting our selection more in detail, let's take a minute to talk about CAD models and how they are different from classic tessellated models, like meshes, usually created in DCC tools like Maya, 3ds Max, Blender, any DCC tool. So a very specific and important thing about CAD models, they are coming from CAD tools like TIA or Inventor or NX, and basically they contain only parametric, mathematically defined surfaces. And these surfaces, they need to be translated into meshes, light meshes, that can be handled by a game engine like Unity. And that's precisely what Pyxis solutions do. So if you take CAD are made of surfaces or bodies that are composed of CAD faces and also called patches. And they are delimited by boundaries. This is the black lines that you see on the breaks on the left side. When polygon meshes from DCC, well, they are dead data. They are non-parametric. So that's the main difference between both. When we talk about CAD models, it usually comes with what we call a product structure. And the engineer, they can add a lot of information on top of that. So what we call metadata. Metadata can be a PMI, a manufacturing information, it can be some material properties, etc. And when we talk about meshes from DCC tools, it's generally a scene graph, very simple one, and no metadata, very, very simple. So it makes a big difference. And also about metadata, the materials are a big part of metadata. And when you talk about CAD models, they usually come as with colors like this, and also sometimes some materials properties, but these properties are not used for visualization. They are used for simulation. You know, they have physical properties. And when we talk about DCC meshes, well, they are meant for visualization purposes, sorry. So they have textual coordinates or UVs, and the idea is to represent a material, how it's being displayed in the reality. So it's quite different. So now, let's take real industrial use cases to present the 3 Pixis solutions for data preparation. So we have Pyxis plugin for Unity, Pixis Studio, and Pyxis Connect, as Geoffrey said. And for the purpose of this demonstration, we use CAD files kindly provided by our friends at Toyota from the Lexus LC500 that you see there. And what we have as input files are thousands of 3D files coming out of CATIA, CATIA being one of the most used CAD design solution on the market. So basically, there can be one Pyxis product for each use case. And depending on the complexity of the use case you are dealing with, you can choose either solution. So to simplify, if your project is to quickly and easily bring CAD data into Unity, then Pyxis plugin is the one you will be using. It's more suitable for small assets, like car brakes here, up to medium complex assemblies. And if you're working on a full car, heavier, more complex model, well, Pyxis Studio is the one you should go to. So basically, Studio is, as Geoffrey said, the original Pyxis tool, the one embedding all the powerful algorithms from Pyxis. And if you wish to finally to scale and repeat data preparation, so if you want to treat many models according to predefined scenarios, well, basically make data preparation workflows available for anyone in the company, then Pyxis Connect is the solution. So basically, from an interactive usage to a fully automatic usage, there is a dedicated Pyxis solution. Now, let's start with the real use case. Let's say we want to import a light CAD assembly to create a simple VR real-time application for CAD model review and using Unity. So in that case, we'll be using the car brakes from the Lexus. Then, as I said before, the plugin for Unity is the right choice there. The plugin comes as a simple Unity package, easy to install and to use, and that will give you the possibility to import up to and more than 20 different CAD formats directly inside Unity. And it's also including AEC formats like Revit or IFC or DWG 3D. And it comes as a very simple interface with understandable, simple settings and presets. And you have a bunch of group boxes to access all these settings. But I won't go too much into details in this presentation of the Pyxis plugin for Unity, since our colleagues from Pyxis, Olivier and Laurent, will be giving a full presentation of the new release 2018.3 version that will be released in November. So they are giving a presentation at 5 this afternoon, so make sure to attend because you will learn a lot of stuff about this product. Anyway, very, very quickly, first, when importing a CAD file, you get to choose your input CAD file. Then you can conform coordinate system and units inherited from the CAD file to your Unity project. Then you have presets to deal with the original CAD hierarchy, meaning you can merge, you can compress, you can merge by materials, etc. And something very important for industrial customers, with the plugin, we managed to preserve all information coming from the original CAD file, so to ensure digital continuity. So we keep Yarra Key, we keep materials and colors, and also metadata that will be delivered in components on parts. Then you move to the mesh quality group box. It's where you will define the quality of the meshes that will be created by Pixie's algorithms. And it comes as presets, so the user benefits Pixie's expertise without needing to know anything about complex settings. Finally, you have more settings. You can create LODs on the fly, you can create UVs, you can deal with faces orientation, etc. And also tons of very cool stuff that you will see in this afternoon's presentation. So after import phase, you end up with ready-to-use assets, on top of which you get to use Unity Power to add behavior for VR use and build the final application. And the result that we see here is an Oculus VR app for CAD model review built with Unity. And another cool feature, an important feature about the plugin is the possibility to use it at runtime. So if you want to create an application, build it with Unity, and you can embed a Pixis plugin to import CAD data at runtime. And so far, it's possible for Windows. So in conclusion, the plugin is quite the auto magic tool. It's good for non-CAD specialists needing to quickly bring CAD data inside Unity. But it's limited for more powerful and controllable data prep strategies. And plugin was made with a subset of Pixis core, and the complete one is Studio, Pixis Studio. So let's move on to industrial use case number 2. There we want to create a full model with materials applied for design review in Unity, a full car model. And for this advanced interactive data prep scenario, well, Studio is the rightful tool. So with Studio, you get all the CAD formats for import and export. It's in ergonomic view, intuitive UI with a robust and powerful viewer, which is necessary to display numerous complex data for a full car assembly. And as I mentioned before, and Geoffrey did too, Studio is the original tool, so combining all Pixis core algorithms with no limitation, which is necessary for dealing with such a complex assembly. So now let's prepare this Lexus for Unity, whilst having a look at the most important algorithm from Pixis toolbox. So first, you get to import all the data. Here in that case, it's more than 3,000 CATIA files. And what you get at this stage in Studio or environments are not meshes. What you see there are what I was talking about before, original CAD surfaces. And it's represented here as gray wireframe, but it's not meshes yet. So once you have a complete car, which is already a performance, you can move on to actual data processing, data treatment. So prior to creating meshes necessary for data visualization, as I said, first step is to repair the original CAD mathematical surfaces. And the goal is to optimize the surfaces, to remove overlapping faces or to stitch potential gaps, and also merge together shattered surfaces that need to be connected together in order to create a good meshes. So as you see there, we went from more than 3,000 parts to around half of that. So we have already started data optimization there. Then we move on to creating meshes. And for that, we are using our best-in-class tessellation algorithms. And here, the result for the full car is 4 million triangles in total. So, but as you can see, we have misoriented meshes. The pink faces that you can see there represent misoriented faces, upside down. So we need to repair that. So as we did for CAD, now we can use algorithms to repair the generated meshes if necessary. And it means mainly orienting correctly all the faces of the model. But sometimes it's simply, it's not enough to obtain a perfectly oriented mesh. So as you can see on the windshield, we still have some pink faces there. And that's why we have a script called Smart Orientation that basically is perfect for this kind of full car model. It's going to automatically orient all the faces. And this powerful feature, consists in automatically placing cameras in the cavities of the car and all the faces will be oriented by simply looking at all the scattered cameras. So a very powerful feature. Then you move on to the material assignment, which is quite a manual process here. And the idea here is to apply materials to the parts, but not just any material. The one for this use case, we want to end up in Unity, you remember? So we want the Lexus to be wearing the materials from the new automotive library that was created by Unity several months ago. So we simply need to apply materials with the same material names. Then we move on to UVs, texture coordinates. And you have several algorithms available to create UVs in Studio. And also a very powerful repack algorithm that can be very necessary for baking light maps in Unity if it's necessary. In this case, it's not necessary. Then you can finalize the preparation by optimizing the Yarra Key. So by merging parts together to create sub-assemblies, potentially by materials, you can create symmetries, etc. And optimizing the product structure can be good for Unity to have simple scene graph to manage, to lower the number of draw calls. And finally, you get to export the final model in one of the export format that we handle in Pixie Studio. It can be FBX, GLTF, USDZ, which is new. And in this particular case, we're going to export as a Pyxis file, which is our proprietary format. But why is that? It's because we want to take advantage of our plugin for Unity. Using the plugin and the Pyxis format, well, you will import more efficiently the model in Unity than using an FBX. And also, providing that your final project contains all the materials from Unity, automotive library, while the materials will be automatically applied. So that's quite a cool feature. And finally, you end up with this, which is a full car model, fully dressed with material for design review inside Unity. Now, this example did not show all Pixie's main algorithms, so just let me talk to you about these ones that we have here. Defeaturing, well, these are the algorithms that will allow you, for example, to remove holes, so through holes, blind holes, surfacing holes, to have lighter meshes. We can also remove small parts. You can define the size of the parts to remove. You can also remove things based on object metadata using scripting. And we also have the smart hidden removal, which is basically the same thing as the smart orient. It's going to place automatically some cameras all around the model, and everything that is not being seen by these cameras will be simply deleted. So you'll have a lower quantity of meshes. Then we have the proxy mesh, which is basically creates a lightweight envelope mesh that can be used as a collision mesh or shadow mesh. And combined with the baking tool that we have, you get to create optimized assets for HoloLens, for example. It can be very, very powerful. And finally, we also offer in Pixie Studio some ready-to-use scenarios. And we have some examples that can help you, show you how to build end-to-end automatic data prep scenarios. So now, how to automate the process that we saw on use case number 2. Well, that's use case number 3. Now that we tailored a good data preparation recipe interactively in use case number 2, how can we deal with a full 150% model of this Lexus and import it in Unity? Well, there you get to use the power of our embedded Python API for scripting. Now, this Lexus model, as I said, is coming from the Lexus PLM system, and it's completely disassembled, as we saw. So thousands of unitary CATIA files that combine together make what we call the 150% mockup, meaning all the existing variants of the digital Lexus. But what rules can we follow to assemble all the variants intelligently? Well, as you can see there, Lexus has what they call an internal solver. And basically, it's coming as a very big Excel sheet that says which unitary parts make parts of each variant, and then what material is applied to this part, what group it's linked to. I mean, for example, what is the left door, what is the hood, what is the seat, etc. So to create the full hierarchy of the car. But anyways, this is one example of how a Camel Models database can be handled, the one from Lexus, but of course, it can be way different from one OEM to another. But simply remember that Pyxis provides as a tool that offers flexibility to adapt to any process. So, well, we created a scenario that basically is going to read this big Excel file, which serves as a rule engine, and it will load intelligently all the parts and execute the step-by-step procedure that we saw with use case number 2. So for that, we use here the new Pixie Studio.batch version. This particular version includes an additional import-export Python function for batch processing, and it's being used there. And basically, in just a few seconds, everything that we've done by hand in the first use case is being automatically executed. And finally, you end up in Unity with a fully prepared and packed 150% car assembly with all the variants possible. And on top of that, if you want, you can create a solver in Unity to create a functional car configurator with multiple variants.
So at the end of the Lexus project, the car data were used by a VR agency called Light and Shadows to create this marketing car configurator in Unity using the HTAP render engine. And then the next step of this project is to deploy a CAD data-driven experience generation platform at Toyota, where Unity applications can be generated on demand. So the idea is to connect the product lifecycle management system of the company to Pyxis Connect platform, which will feed Unity experience template with fresh and optimized CAD data. So the car configurator, which just shown you before, is an example of the experience that could be templatized. And this is what Pyxis Connect frontend looks like. So it's simply a web page that can be administrated like this. And typically, the user selects the CAD data input, then chooses an optimization scenario that has been coded in Pixie Studio. And so at the end of the process, the user downloads the result, whether it is an optimized asset or a built application, if a Unity application template has been provided. This is our new 2018.3 offer that will be released next month. So feel free to pay us a visit at our booth downstairs. We have some new demo regarding Pyxis Connect, exporting CAD data in USDT format for AR on iOS. And if you have questions, please feel free to ask. Thank you for attending.
Thank you. Questions? Anyone? Yes?
Do you guys have any plans to integrate PLM change notices?
All right, sorry, I didn't get, can you use the microphone, please?
Do you guys have any plans to integrate with PLM systems that use change notices? So as there's an update to a vehicle subsystem, it would update through Pyxis. One of the big difficulties we have is just keeping up with model changes.
This is a question we often have. Maybe we do something off the shelf for certain of the major PLM system. I'm thinking about Teamcenter from Siemens, Windshield from PTC. But usually in creating a connector between a PLM system and Pyxis, or whatever other system it is, it's usually something very bespoke because you don't know in advance what kind of metadata you want to retrieve or 3D models you want to retrieve from the PLM system. Usually it's really a project that requires some consultancy. So what we do, we work with integrators in that case So with the saw, they can really know how to create this kind of integrator. So it's difficult to have something generic, but we think about some generic connectors from the ones I mentioned before.
Yes, please.
Is there a sort of an API that you can use before the web front end of the device? Because that's what it is, right? We have a change in registration process, then towards the end of that process, we can call an API that runs the front end.
So your question, is there a Pyxis API that you would use with other... Sorry?
Yeah, exactly. So
okay.
the web front end that you guys showed towards the end, can
yeah.
I call an API that runs the security?
Yes. So Pixie Studio is the first step for doing what you are describing, because there is a Python scripting API inside. And once you have developed your script, you can export it as a Python file. And we have an offer, which is Pixis Batch. And this is a simple exe file that you can run through commands. And this tool, you can feed it with a Python file, or you can directly open this exe tool and just type some commands using Python. So it's a way to directly code what you need without any GUI or whatever. So you can integrate that into another solution or something on top of it.
Yes.
Yeah. Typically, most of our customers use our tools offline for confidentiality reasons. So all the tools you see in this offer can be used offline, and especially the Pyxis Connect, we allow our users to download it and install it on their private cloud system.
You mentioned that you have runtime import for Windows. Do you have runtime import for HoloLens? Have you done anything with that?
Not yet.
Not yet. Sorry, it's on the roadmap.
It's on the roadmap for next year, yes.
The runtime feature for the Unity plugin for now is only on Windows. Next step will be for macOS, and then HoloLens and so forth.
The idea here would be to use our automated solutions to create asset bundles, then to feed that to your Unity application to be used on the HoloLens. It's a workaround for the moment. Any other question?
So again, feel free to visit us downstairs if you have a question, or if you want to see some demos, we can explain you some stuff in details there.
Thank you, guys.
Thank you.
Thank you.